Imagine that we are travelers from the stars, bound for the sun. We would discover it surrounded by 4 giant, cloudy gas worlds, blue Neptune and its frozen moon Triton. And then, farther in, Uranus and its dark rings, made perhaps of organic matter. Saturn, the jewel of the solar system, set within concentric rings, composed of 1 billion icy moons. And finally, flanked by massive satellites, the largest planet, Jupiter. Its multicolored clouds studded with flashes of lightning. Still farther in, closer to the sun, there are no more giant planets. Only a host of lesser worlds made of rock and metal, some with a thin envelope of air. They huddle about the sun with almost no internal heat of their own. Tiny places with solid surfaces, one of which is a blue and pretty world called Earth. Half covered with clouds, it is the home planet of travelers who have just learned to sail the sea of space. To investigate close up Jupiter, Saturn, Uranus, and Neptune, its brothers and sisters in the family of the Sun. Human voyages of exploration to the outer solar system are controlled, so far, from a single place on the planet Earth, the Jet Propulsion Laboratory of the National Aeronautics and Space Administration in Pasadena, California. Here, on Sunday, July 8, 1979, the Voyager 2 spacecraft began its close passage by Jupiter and its moons.
I think I just had. We have to call first. We have to call. Yeah, I think they will.
General Science Systems.
Are you ready with detailed status check?
Yes, I am.
The spacecraft had been instructed how to explore the Jupiter system by a sequence of commands radioed earlier to its onboard computers.
Output power, 450 watts. Power is go at this time.
DSE systems.
DSE.
Detailed status check?
Okay, LACP mode is far encounter. We are at tick 210. The direction last recorded was reverse, and the track is track 1.
Here we check how faithful an emissary Voyager is. Does it understand the commands? How is its health, its temperature, its brains, its heart?
Yes, about 30 minutes, so they don't know if they got
Space systems.
Yeah, we've just completed the detailed status check, and the spacecraft is go following the ring plane crossing.
The modern ships that sail to the planets are unmanned. They are beautifully constructed, semi-intelligent robots. Voyager's eyes are 2 television cameras designed to take tens of thousands of pictures in the outer solar system. Along with other instruments, they are mounted on a scan platform which points at passing planets. Voyager's brains are 3 integrated computers set amidships. It communicates with Earth through a large radio antenna mounted like a sail. Voyager bears a message for any alien civilization it may one day encounter in interstellar space. Its louvers open and shut to help control the onboard temperature. But Voyager cruises so far from the sun that it cannot depend on solar power. Instead, it has a small nuclear power plant, quarantined from the rest of the ship. Many things can go wrong in such pioneering missions, so people are a little uneasy at Voyager mission control. Jupiter is surrounded by a shell of invisible but extremely dangerous high-energy charged particles. If Voyager flies too close, its delicate electronics will be fried. A collision with a small boulder in the rings of Jupiter could send the spacecraft tumbling wildly out of control, its antenna unable to find the Earth, its data lost forever. Voyager 1 and Voyager 2 were launched a month apart in late summer 1977. After many alarms and close calls, they successfully arrived months apart at the Jupiter system, where they worked brilliantly, providing the first close-up views of mighty Jupiter and its 4 large and mysterious moons. Io, the innermost of the 4, Europa, and, moving away from Jupiter, Ganymede, and the outermost big moon, Callisto. In a mission that cost a penny a world for every human on the planet Earth. Voyager's passage by Jupiter accelerated it towards a close encounter with the planet Saturn. Saturn's gravity will propel it on to Uranus, and in this game of cosmic billiards after Uranus, it will plunge on past Neptune, leaving the solar system and becoming an interstellar spacecraft, destined to wander forever the great ocean between the stars. And if Voyager should, sometime in its distant future, encounter beings from some other civilization in space, it bears a message, a phonograph record, golden, delicate, with instructions for use. And on this record are a sampling of pictures, sounds, greetings, and an hour and a half of exquisite music, the Earth's greatest hits. A gift across the cosmic ocean from one island civilization to another. The record bears, in English, an additional little handwritten greeting. It says, "To the makers of music, all worlds, all times." These voyages of exploration and discovery are the latest in a long series which have characterized and distinguished the human species. In the 15th and 16th centuries, you could travel from Spain to the Azores in a few days, the same time it takes now to cross that little channel from the Earth to the Moon. It took then a few months to traverse the Atlantic Ocean and reach what was called the New World, the Americas. Today it takes a few months to cross the ocean of the inner solar system and reach Mars and Venus, which are truly and literally new worlds awaiting us. In the 17th and 18th centuries, you could travel from Holland to China, say, in a year or two, the same time it takes now for Voyager to travel from the Earth to Jupiter. And in comparison to the resources of the society, it cost more then to send sailing ships to the Far East than it does now to send spaceships to the planets. The passion to explore is at the heart of being human. This impulse to go, to see, to know has found expression in every culture. Africa was circumnavigated by Phoenician sailors in the employ of an Egyptian pharaoh in the 7th century BC. The islands of the Pacific were settled by skilled and heroic navigators from Indonesia. Great fleets of ocean-going junks left the ports of Ming Dynasty China to explore India and Africa. A century later, 3 ships left Spain under the command of an Italian navigator to discover the Americas. And then a Portuguese expedition succeeded in sailing all the way around this blue globe. These voyagers of many cultures were the first planetary explorers. They have bound the Earth up into one world In our exploration of other worlds, we follow in their footsteps. Our present spaceships are the harbingers, the vanguard of future human expeditions to the planets. We have traveled this way before, and there is much to be learned by studying those great voyages of a few centuries ago. In the 17th century, the citizens of the new Dutch Republic pursued a course of vigorous planetary exploration. Holland was then a revolutionary society. It had just declared its independence from the powerful but stagnant Spanish Empire. And with a newfound self-confidence, Holland embraced, more fully than any other nation of its time, the spirit of the European Enlightenment. It was a rational, orderly, and creative society. But because Spanish ports and vessels were closed to the Dutch, the economic survival of the tiny republic depended on its ability to construct, man, and operate a great fleet of commercial sailing vessels. The Dutch East India Company was a combined governmental and commercial enterprise which sent shipping to the far corners of the world to acquire rare commodities and resell them at a profit in Europe. Such voyages were the life's blood of the Republic. Navigational charts and maps were classified as state secrets. Ships sometimes left with sealed sailing orders, the crews embarking for an unknown destination more than a year away on the far side of the planet. These expeditions were not only commercial exploitations, although there was certainly plenty of that. Besides the usual appeals of ambition, greed, national pride, and the thirst for adventure, the Dutch were also motivated by a powerful scientific curiosity and a fascination with all things new. New lands, new peoples, new plants and animals. This building, then the Amsterdam Town Hall, still attests to the hardy self-assurance of its 17th century architects. Its lavish crystal adornments still reflect the glittering pride they felt in their accomplishments and their prosperity. It took shiploads of marble to build this place. Constantine Huygens, a poet and diplomat of the time, said that this town hall dispelled what he called the Gothic squint and squalor. The Middle Ages had ended. The Enlightenment had begun. Up there, do you see, is Atlas supporting the heavens on his shoulders. And beneath is Justice with a golden sword and golden scales, flanked by death and punishment. And who is it that Justice is trampling underfoot? Why, it's avarice and envy, the gods of the merchants. The Dutch knew that the unrestrained pursuit of profit posed serious threats to the soul of the nation. A less allegorical symbol is down here on the floor. It is a great inlaid map stretching from West Africa to the Pacific Ocean. The whole world was then Holland's arena. In a typical year, many sailing vessels set out halfway around the world for the Far East on voyages of exploration and discovery, of trade, journeys taking years to accomplish, down the west coast of Africa, through what they called the Ethiopian Sea, skirting the southern coast of Africa, through the Straits of Madagascar, and on past the southern tip of India to the Spice Islands, present-day Indonesia. Another set of voyages went south and east to New Holland, later renamed Australia. And still other journeys ventured through the Straits of Malacca to the Empire of China. But Holland was a small country, forced to live by its wits. There was a strong pacifist element in its foreign policy. Never before or since has Holland boasted such a galaxy of scientists, mathematicians, philosophers, and artists. This was the time of the great painters, Rembrandt and Vermeer. Because Holland was tolerant of unorthodox opinions, it was a refuge for intellectuals fleeing the thought control and censorship of other parts of Europe, much as the United States benefited enormously in the 1930s from the exodus of intellectuals from Nazi-dominated Europe. And so it was that 17th century Holland was the home of the great Jewish philosopher Spinoza, who Einstein admired so much, of René Descartes, a pivotal figure in the history of philosophy and of mathematics, and the home of a political scientist named John Locke, who was to have a powerful and profound influence on a group of philosophically inclined revolutionaries named Paine, Hamilton, Adams, Franklin, and Jefferson. The Dutch University of Leiden offered a professorship to an Italian scientist named Galileo, who had been forced by the Catholic Church under threat of torture to recant the heretical position that the Earth went around the sun and not vice versa. Galileo had close ties with Holland. His first astronomical telescope was based on a spyglass of Dutch manufacture, and with it, he discovered the craters of the moon, the phases of Venus, and the 4 large moons of Jupiter. Becoming an exploratory power made Holland a vital intellectual and cultural center as well. The improvement of sailing ship technology spurred technology in general. A key problem in navigation was the determination of longitude. Latitude could be determined easily. The farther south you were, the more southern constellations you could see. But longitude required precise timekeeping. An accurate shipboard clock would continue to keep the time in your home port. The rising and setting of the stars would give you the local time, and the difference between the two would tell you how far east or west you had gone. Technological advance required the freest possible pursuit of knowledge. So Holland became the leading publisher and bookseller in Europe, translating works written in other languages and printing books that had been censored elsewhere. Adventures into exotic lands and encounters with strange societies shook complacency. They challenged the prevailing wisdom and showed that ideas which had been accepted for thousands of years might be fundamentally in error. In a time when kings and emperors ruled much of the planet, the Dutch Republic was governed, more than any other world power, by the people. They enjoyed a certain material well-being, but the interiors of their houses, celebrated by a generation of Dutch painters, suggest restraint and discretion. The officers of these ships of exploration and trade would return from their long voyages, share in the goods they had acquired, and discuss the wonders they had encountered. Holland prospered in its freedom of thought. In Italy, Galileo had announced other worlds. Giordano Bruno had speculated on intelligent life elsewhere. For this, they were made to suffer brutally. But in Holland, the astronomer Christian Huygens, who strongly supported both ideas, was showered with honors. Christian was the son of Constantine Huygens. The elder Huygens distinguished himself as a master diplomat of the age, a man of letters, a close friend and translator of the English poet John Donne. Constantine Huygens was also an accomplished composer and musician. It was Constantine who had discovered a young painter named Rembrandt van Rijn, in several of whose works he subsequently appears. He opened the doors of his house to artists, musicians, writers, statesmen, and scientists. A feast of goods and ideas from all over the world awaited them. The philosopher Descartes, who visited him here, said of Constantine Huygens, "I could not believe that a single mind could occupy itself with so many things and acquit itself so well in all of them." He even excelled at the art of parenthood. He was a tender and loving father. His son Christian flourished in this rich environment, demonstrating extraordinary talents for languages, drawing, law, science, engineering, mathematics, and music. "The world is my country," he said. "Science, my religion." Light was the motif of the age, the symbolic enlightenment of freedom of thought and religion, the light that suffused the paintings of the time, and light as an object of scientific study. The microscope was invented in Holland at this time and became a drawing room curiosity. Its inventor was a friend of Christian Huygens, a man named Anton Leeuwenhoek. The first microscopes were developed from magnifying glasses used by drapers to examine the quality of cloth. Leeuwenhoek and Huygens are the grandfathers of much of modern medicine. Because, to his amazement, Leeuwenhoek discovered a universe in a drop of water, the microbes, which he described as animalcules, and thought cute. Leeuwenhoek and Huygens were among the first people to see human sperm cells, a hitherto hidden microcosm of the human life cycle. Leeuwenhoek had discovered the microbial world. Huygens had argued from his telescopic observations that Mars was another world, and probably an inhabited one. What a waste of a planet, he thought, if Mars were barren. So the Viking search for microbes on Mars can be traced directly back to Huygens and Leeuwenhoek in 17th century Holland. The telescope and the microscope developed here represent an extension of human vision to the realms of the very small and the very large. Our observations of atoms and galaxies were launched in this time and place. From the bending of light through a lens, Huygens advanced the idea that light was a kind of wave. He ground and polished lenses for the successively larger telescopes he constructed, although it did take him a time to figure out how to use them properly. Huygens was the first person to see a surface feature on the planet Mars. He was the first person to speculate that Venus is completely covered with clouds. He was the first person to understand the nature of the rings of Saturn. Saturn is surrounded, he wrote, by a thin, flat ring which nowhere touches the body of the planet. His discoveries with the telescope would by themselves have ensured his place in the history of human accomplishment. Huygens was the discoverer of Titan, the largest moon of Saturn. The immense size and changing clouds of Jupiter entranced him. Astronomers, as well as navigators, need accurate clocks to time the movement of the heavens. Huygens was the inventor of many precision timepieces, including the pendulum clock. To illustrate the sun-centered universe of Copernicus, he built computers that reproduced the clockwork of the heavens from Mercury to Saturn. The machines he designed, he signed. Christian Huygens, inventor. He was delighted that the Copernican system was widely accepted in everyday life in Holland and acknowledged by all astronomers except those, he wrote, who were a bit slow-witted or under the superstitions imposed by merely human authority. Across the sea of space, the stars are other suns, a point which Huygens appreciated perfectly well. He reasoned that if our planetary system involved a sun and planets going around it, that those other suns should likewise have a retinue of planets going around them, and also that many of the other planets were inhabited. He set forth these conclusions in a remarkable book bearing the triumphant title, The Celestial Worlds Discovered. The subtitle is Conjectures Concerning the Inhabitants, Plants, and Productions of the Worlds in the Planets. He wrote this book sometime shortly before his death in the year 1690 in this study. By and large, Huygens imagined that the environments of the other planets, and also the inhabitants of the other planets, were pretty much like those of 17th century Europe. I wonder if he imagined traveling to those other worlds which he had been the first to examine close up through the telescope. Perhaps he dreamt that voyages of discovery to the planets would one day be rather like the voyages of geographical discovery in his time and place. He did imagine of extraterrestrial beings that their whole bodies and every part of them may be quite distinct and different from ours. 'Tis a very ridiculous opinion, he says, that it is impossible a rational soul should dwell in any other shape than ours. You could be smart, Huygens was saying, even if you looked funny. But he then went on to argue that they didn't look all that funny, that extraterrestrial beings must have hands and feet and stand upright and have writing and geometry, and even that the 4 big moons of Jupiter, the Galilean satellites, were there in order to provide a navigational aid, a convenience for the sailors in the Jovian oceans. Well, maybe. That bit of speculation is probably wrong, but think of a citizen of the 17th century with the courage and insight to imagine other landscapes and other intelligences. Might there really be mariners on a million other worlds? In his book, Huygens wrote, "What a wonderful and amazing scheme have we here of the magnificent vastness of the universe. So many suns, so many earths, and every one of them stocked with so many animals, adorned with so many seas. How must our wonder and admiration be increased when we consider the prodigious distance and multitude of the stars." The Dutch called their ships flying boats, and the Voyager spacecraft are their descendants, true flying boats, bound for the stars and on the way, exploring some of those worlds which Christian Huygens, a man from Earth, knew and loved so well. Travelers' tales, one of the main commodities returned by those sailing ship voyages of centuries ago, were stories. Stories of alien lands and exotic creatures. They evoked the sense of wonder and stimulated further exploration. Those tales of strange worlds enabled some Europeans to see themselves anew. There had been accounts of headless people, foot people, cyclops people. Now, the Dutch brought back fantastic stories of giant hunters, dodos, rhinos, leopards, and other creatures. Modern voyagers also return travelers' tales, tales of a world shattered like a crystal sphere. A place where the ground is covered with what looks like a network of giant cobwebs. A world with an underground ocean. Tiny moons shaped like potatoes. A yellow and red pockmarked land with lakes of molten sulfur and volcanic eruptions 300 kilometers high. And a place called Jupiter, so large that 1,000 Earths would fit inside. There are no mountains, valleys, volcanoes, or rivers there, just a vast ocean of gas and clouds. Everything we see on Jupiter is floating in the sky. But there's much that is fascinating about Jupiter. As the solar system condensed out of interstellar gas and dust, Jupiter acquired most of the matter that wasn't ejected into interstellar space and which didn't fall inwards to form the sun. Jupiter is made mostly of hydrogen and helium, just like the sun. And had Jupiter been a few dozen times more massive, the matter in it might have undergone thermonuclear reactions in the interior, and Jupiter would have begun to shine by its own light. Jupiter is a star that failed. Had it become a star, we would be living in a double star system with 2 suns in our sky, and the nights would come more rarely. Deep below the clouds of Jupiter, the weight of the overlying layers of atmosphere produce pressures which are much greater than any that are found anywhere on the Earth. The clouds are just this little layer here. The deep interior is this high-pressure place. The pressure is so large that electrons are squeezed off hydrogen atoms, producing liquid, metallic hydrogen. But at the very core of Jupiter, there may be a lump of rock and iron, a giant Earth-like world under astonishing pressures, hidden forever at the center of the largest planet. Just before Voyager encountered Jupiter, you could see that giant planet at night shining in the sky, as our ancestors have for the last million years. And on my way to study the Voyager data arriving here at the Jet Propulsion Laboratory, I thought that Jupiter would never be the same again. Never again just a point of light in the night sky, but forever after, a place to be explored and known. To see the first close-up images of a world never before known, this moment is one of the greatest joys in the life of a planetary scientist.
Yeah, it's moving that way. We're moving this.
In the early morning hours of July 9, 1979, on the real-time television monitors at the Jet Propulsion Laboratory, we began to learn about a world called Europa. These are the modern explorers, men and women trained in astronomy, physics, geology, or engineering. Many of them have devoted 5 to 8 years to this single mission.
Cassin's model for Europa says that if you started off with it liquid, you could probably pump in enough energy to keep it liquid.
Let's see.
But the Cassin thing said that in order for there to be enough heating going on, you sort of had to start the heating before Europa basically cooled off, as I recall.
Yeah, but Gene, what about the relief from the cracks? Shouldn't the cracks anneal and flow also? They got to be being renewed.
The Io and Europa, there's a twin, a pair there, and then there's a pair out of Ganymedes Callisto.
You can't look at the surface of a world so different from ours without wondering how both were made.
Just rotate it out a little bit.
Voyager presented us with 6 new worlds in the Jupiter system alone.
Maybe.
The more you learn about other worlds, the better you understand our own. We speculate, criticize, argue, calculate, reflect, and wonder. We return again and again to the astonishing data. And slowly, we begin to understand. The Dutch sailing ships brought back rare and valuable commodities from the new worlds they visited. Our Voyager spaceships return rare and valuable information to computerized wharves on this shore of the Sea of Space. Here the data are unloaded to be stored, enhanced, processed, and treasured. Maps of alien lands will be generated from this information. In this electronic warehouse are tens of thousands of images of previously unknown worlds. How does a picture from the outer solar system get to us? Sunlight shines on Europa and is reflected back to space, where some of it strikes the phosphors of the Voyager television cameras, generating an image. The image is radioed back across the immense intervening distance of 500 million kilometers to a radio telescope on Earth, one in Australia, say. The telescope then passes the information via communications satellite in Earth orbit to Southern California. There, it's transmitted by a set of microwave relay towers to a computer at the Jet Propulsion Laboratory. And there, it is processed. The picture is fundamentally like a newspaper wire photo, made of perhaps 1 million individual dots of differing shades of gray, so fine and close together that at a distance, the constituent dots are invisible. We see only their cumulative effect. The information from the spacecraft specifies how bright or dark each dot is to be. After processing, the dots are then stored on a magnetic disk, something like a phonograph record. By this day, there were already 11,000 pictures from Voyager 2 in our electronic library. Finally, the end product of this remarkable set of links and relays is a hard copy which comes out of this machine showing, in this case, the wonders of Europa, which were recorded for the first time in human history today. is absolutely astonishing. See, Voyager 1 got very good pictures of the other 3 big moons, Galilean satellites of Jupiter, but not of Europa. It was left to Voyager 2 today to get the first close-up pictures of Europa, where we see things that are only a few kilometers across. And at first glance, it looks like nothing so much as the canal network of Mars that Percival Lowell imagined to exist on that planet. We see an amazing, intricate network of crisscrossing straight and curved lines. Are these straight lines ridges? Are they troughs? Is it connected with plate tectonics on the Earth? How does it illuminate the other satellites of the Jovian system? At this moment, the vaunted technology has produced something astonishing, but it remains for the limitations and cleverness of another device, the human brain, to figure it out. Fortunately, we have plenty of pictures to help us.
What about Gene's idea of geysers down the troughs?
Geysers down the troughs. Well, you got to have a mechanism to drive it.
Larry Soderblom, Voyager
proposed,
imaging team.
Some wild idea a few months ago that we might have sort of champagne bottle models. And what that is you seal the crust and you have liquid underneath that solid crust.
The question is, do you have that kind of condition, which is an explosive?
Lonnie Lane, deputy project scientist.
Over a large area, and I thought you'd have enough resolution with some of these pictures that you don't see something that is spread laterally.
Do we have the high-resolution piece to blow up?
Yeah, it was here somewhere.
There it is.
There you go.
Yeah. This is where we pick out the relief, and if we're going to see the things we can recognize. This is what I was
Weeks after the pictures from Europa were received, we were still debating what was in them.
It's as if we almost got to the, here's another thing, look at the little mesas here.
Yeah, very bright.
We almost got to the limit of resolution required to see the craters which would last indefinitely on a crust this thin.
Apart from the Rousseaus, there's a set of very fine, small dots, markings, which are mostly in the model terrain. Like those guys. Now, do you think those are sites of outgassing, calderas, fumaroles, solfataras?
I don't know, but I'll tell you one thing I just picked up. Let's look at this.
Yeah, all right.
Look right here. It disappeared. Look right there. Look at
that's
you see a central peak?
Yep.
You see a
little hole.
Yep, it's a, I almost see a radiating crater. I think it's got to be an impact crater. Look at the central peak on it.
There's almost no impact craters on this planet.
Well, wait. We just found one.
Almost none. Therefore,
finding one which is alleged to be the exception, maybe it's not the exception, but something else.
Perhaps, but on the other hand, you asked about all those little holes that we can't quite make out.
So you'd argue that the
resolution limited on these.
The big craters go away by some rheological deformation, and the little ones stay, but they're just at the edge of our resolution.
That's because they're 1/10 the depth of the solid, the rigid crust.
Well, maybe. Computer processing of the pictures has revealed at least a few features on Europa which seem to be impact craters, but something has wiped out the big craters. Computer processing also played a major role in one of the most amazing Voyager discoveries made on the moon next door to Europa, a world called Io. Even from Earth, we could tell that Io had a strange color. We knew that somehow sulfur had been removed from its surface and ejected into a great donut of gas orbiting Jupiter. Then, Voyager 1 sailed close to Io. There were a few places on Io which looked like the mouths of volcanoes, but it was hard to be sure. Then, Linda Morabito, a member of the Voyager navigation team, used a computer to enhance a picture of the edge of Io in order to bring out the stars behind.
4 days after the Voyager 1 encounter with Jupiter, I was looking at an optical navigation frame. Now, in enhancing this particular quadrant, became very evident to me was an anomalous crescent in the upper left-hand corner just off the limb of Io.
What was it? The plume turned out to be exactly in the position of one of the suspected volcanoes.
So basically, we realized at that point that what we were observing was a volcanic plume, and in fact, a volcanic eruption.
Voyager had discovered the first active volcano beyond the Earth. We then found that Io has many volcanoes. There are at least 9 intermittently active plumes and hundreds, maybe thousands of extinct ones. The plumes can eject sulfur and other atoms off Io altogether and account for the sulfur clouds surrounding Jupiter. Rivers of molten sulfur flow down the sides of the volcanic mountains and are the probable source of Io's distinctive colors. The volcanoes may be tapping some vast underground ocean of liquid sulfur beneath a surface that is only a few thousand years old. So far, in our voyages to the outer solar system, we humans have stayed home and sent our robots and computers to explore in our stead. Someday, perhaps, we'll go ourselves. But suppose, like those Dutch sea captains of the 17th century, the computers aboard Voyager could keep a ship's log. That log, a combination of the events of Voyagers 1 and 2, might read something like this. Day 1. After much concern about provisions and instruments, we successfully lift off from Cape Canaveral on our long journey to the planets and the stars. Day 13. We have taken the first photograph of the Earth and Moon as worlds together in space. A pretty pair. Day 170. A problem in the deployment of the boom that supports the Science Scan platform. If the problem is not solved, we will be unable to take most of our pictures. Day 207. Boom problem solved, but failure of main radio transmitter. If the backup transmitter also fails, no one on Earth will ever hear from us again. Day 215. We cross the orbit of Mars and enter the main asteroid belt. Day 570. We can now make out finer detail on Jupiter than the largest telescopes on Earth have ever obtained. Day 640. The cloud patterns are distinctive and gorgeous. No painter trapped on Earth ever imagined a world so strange and lovely. The white clouds are ammonia crystals, high and cold. We do not know the nature of the red-brown clouds. Maybe phosphorus or sulfur is a stain, or perhaps complex organic molecules of the sort that led 4 billion years ago back on Earth to the origin of life. And what is the Great Red Spot? It is an immense swirling column of gas reaching high above the adjacent clouds, so large that it could hold half a dozen Earths. Its motion hypnotizes us. Some think that the red spot is a great spinning storm, 1 million years old. Day 650, Encounter, a day of wonders. The ship maneuvers so we can take pictures of the multi-ringed basin on Callisto. Images of the astonishing lined surface of Ganymede. A close passage by Europa. And a view of volcanic Io. We successfully negotiate the treacherous radiation belts and accomplish the ring plane crossing. Looking back, we marvel at the rings and see the sun emerge from behind the giant planet. We are outward bound on our mission to explore the outer solar system. 10,000 years from now, Voyager will plunge onward to the stars. We have made the ships that sail the sea of space. We travel past Jupiter 750 million kilometers from the Sun, Saturn 1.5 billion, Uranus 3 billion, and Neptune 4.5 billion kilometers away. In our ship of the mind, we retrace the itinerary of the two Voyager spacecraft on their journeys to Saturn and beyond. Saturn was first glimpsed through the telescope by Galileo, its rings first understood by Huygens, but only now do we begin to penetrate its deeper mysteries. Saturn is the second largest planet in the solar system. Like Jupiter, it is cloud-covered and rotates once every 10 hours. It has a weaker magnetic field, a weaker radiation belt, and a grand, magnificent, exquisite system of rings. The rings are composed of billions of tiny moons, each circling Saturn in its own orbit. The biggest gap in the rings is called the Cassini division, after the colleague of Huygens who first discovered it. There are many other gaps, each produced by the periodic gravitational tugs of one of the larger outer moons. From just beneath the ring plane, we see a sky full of moons. Within the rings, the individual moons become visible. They are orbiting chunks of snow and ice, each perhaps a meter across. In young parts of the ring system, there has not been enough time for collisions to round the edges of these fragments, the snowballs of Saturn. Far from the rings, bathed in its red light, we encounter Saturn's immense cloud-covered moon, Titan. It has an atmosphere denser than that of Mars, and a thick layer of red clouds which are probably composed of complex organic molecules produced by solar ultraviolet light and other energy sources from the methane-rich air. No ship from Earth has ever penetrated those clouds and viewed close up the surface of this tantalizing world. It seems likely that the ground is covered, encrusted with organic molecules raining from the sky. There may be volcanoes and valleys of ice, and just perhaps, hiding in the warm places, some very different kind of life. Near an ice cliff of Titan, through a rare break in the clouds of organic molecules, we can see, looming and lovely, the ringed planet Saturn. It is a view that will still be appreciated centuries from now by our descendants, who will know it well as we have come to know Hudson's Bay and the Barents Sea, Indonesia and Australia and New York. They will look back to the time when Titan was first glimpsed by the Voyager spaceships on their epic journeys past the giant planets, out of the solar system, to the great dark between the stars. Since Cosmos was first shown, Voyager spacecraft have explored the systems of the planets Saturn, Uranus, and Neptune, and have now passed the outermost planets on their way to the stars. We inserted a flavor of those encounters in our captain's log, but with image processing, we've been able to reconstruct astonishing movies of some of these worlds. Here, for example, is Jupiter with its great red spot, and volcanic Io spinning before us. Icy Enceladus, a tiny moon of Saturn on much of which, somehow, the craters have melted. And Miranda of Uranus. Austere blue Neptune. Or consider Titan, the giant moon of Saturn. We've taken the nitrogen and methane in its atmosphere, irradiated it in the lab with electrons of the sort that are beamed at Titan from Saturn's magnetic field, and we make this stuff, which matches almost perfectly the observed properties of the Titan haze. What is it? It's a mixture of complex organic molecules. You drop some of the stuff into water, and among other things, you make amino acids, the building blocks of proteins. So the starting materials of life are raining from the skies of Titan like manna from heaven. I can't wait until the Cassini mission sends an entry probe through the organic haze of Titan to its enigmatic surface. The Voyager spacecraft rush on past the planets and to the stars, still returning data. As it left the planetary part of the solar system, Voyager 1 turned back to take one last portrait of the planets of the solar system. And one of those pictures was of the Earth, a tiny blue dot set in a sunbeam. Here it is. That's where we live. That's home. We humans are one species, and this is our world. It is our responsibility to cherish it. Of all the worlds in our solar system, the only one, so far as we know, graced by life.